Good morning.
Good morning.
Good morning, boss.
Morning.
Yeah.
Good morning.
Okay, girls. Now, before we start, girls, does anybody have any questions about period, frequency, and wavelength? Any crazy question, it doesn't really matter. About the relationships. Between period, frequency, and wavelength. How to calculate the wavelength.
Yes, can you go over
Soft tissues.
the way, but sir, you asked if we have any questions, so that's my question. If you can go over like the last part of class where the wavelength, just calculating the wavelength again, that's it.
Okay, listen. So the wave, okay, you can say, okay, calculating the wavelength in relation to frequency is not as simple as determining the period of a frequency or relation to the frequency. So you may say, yes, okay, what is the wavelength? Yeah, so the formula is going to be as okay, we can say it's okay, wavelength. And please keep in mind, go that this is only going to, yes, okay, this formula has only 4. soft tissue. Clear? Why? Because they use this unit here, or they use this constant value here. Okay, and that's why it's okay. Your wavelength in this way here is okay, will be as okay, determined in millimeters divided by your frequency. And that frequency is going to be as okay, the frequency expressed in megahertz. Clear? So if we said okay, that the frequency of the transducer was 1 megahertz. In that case, is your wavelength going to be maybe it's okay 1.54 divided by 1, which is nothing else but just 1.54 millimeters. Did that make sense? Now, we can say it's okay if we may say, okay, what's going to be the wavelength? If the frequency of your transducer is 2 megahertz, then that's just 15 point or 1.54 divided by 2, which is roughly 0.77. Okay, and let me just tell you guys, this 1.54, okay, divided by 2, that's a calculation that you're going to come across again and again and again and again. So just remember that, okay, that's the value. 0.77777. You can go on with the sevens. Clear? But we can still say it's okay. So that's going to be as okay, your wavelength. Okay. In millimeters. You can go on and say it's okay, what if what's going to be as okay, the wavelength of a sound wave in soft tissues. If the frequency, for instance, okay, was 3 megahertz. In that case, that's okay, your wavelength is going to be 0.5 millimeters. Yeah, you can even go to the extreme and say, it's okay, what if the wave, what's going to be the wavelength of the sound wave in soft tissues? If your frequency, for instance, okay, was 15 megahertz, then it's going to be as okay, 1/10 of a millimeter. Or we can say it's okay, 0.1 millimeter. Where 0.1 means it's okay, it's just going to be the same as saying 1/10. Or you can even go and say it's okay, 0.1 multiplied by 10 raised to the power minus 3 of a meter. Yeah, this is meaning it's okay, just the 1/10. This 10 raised to the power 1/10, or 10 raised to the power minus 3 is a milli of the unit here. Clear? So it's mainly as okay, just straight out division. But you can say mainly says okay, the most common, yes, okay. Division of 1.54 that you may come across is going to, yes, okay, be divided by 2. That's going to, yes, okay, be repeat. That's a piece of math that you'll come across in following chapters as well. So it's probably going to be easier that you just remember, okay, that's the value. 1.54 divided by 2 is 0.77.
I have a question.
Yo,
So the frequency will always be a whole number, correct?
how many?
The frequency will always be a whole number, like we will always be like a 3.
No, it's not necessarily to be a whole number.
Okay, I'm just asking.
Why? Because you can say it's okay. Now I may say it's okay. Let's say that we have a frequency of 150 kilohertz. Right, okay, that's a frequency. Now here it's okay, it is written as a whole number. But that's also, it's okay, going to be equal to, it's okay, 1.5 megahertz. So no, it's not a whole number.
So, sir, if you get like a question like this, do you have to convert it into megahertz
You will have to,
before you do find the frequency?
exactly. So you have to know that, okay, in this formula here, the frequency has to be expressed, okay, has to be as okay, the frequency in megahertz. You may be given, yes, okay, you can say, as okay, a frequency in kilohertz. Or you may have been given, yes, okay, a frequency in gigahertz. In both cases, yes, okay, if you want, yes, okay, apply it into this formula here, you will have to, yes, okay, find its work in megahertz. Because you said, okay, 2 megahertz, that's going to be, yes, okay, 2000 kilohertz. Now, if you say, okay, well, I don't know the frequency, and you put 2000, then your number here is going to be, yes, okay, 0.000 77 millimeters. Clear? There, okay, as if 2 megahertz is expressed in, or the worth of 2 megahertz is expressed in using gigahertz, is going to be 0.002 gigahertz. So if you put just okay that and divide 1.54 by 0.022, then you're going to just okay getting, no, sorry, 7,700 millimeters, which means to me that you said, okay, yes, the wavelength is 7.7 meters. Okay, so it's not always going to be that you're going to, yes, okay, be given, yes, okay, the frequency in megahertz. It may be given in kilohertz, it may be given in gigahertz, but then you have to convert it from giga to megas or from kilos to megahertz, because yes, okay, here in this formula, the frequency is going to be megahertz. Is that clear?
Yes.
That's mainly, okay, just a second here. Why megahertz? Why is this here millimeters? Now that's all going to be as okay, something because this value here, as I said yesterday, okay, 1.54, that's actually taking us, okay, from the speed of sound. In soft tissues. Clear? Whereas, okay, the megahertz, that's mean that's okay, going to be as okay, because okay, that speed of value is going to be as okay, this many millimeters per microsecond. Okay, guys? So for now, yes, okay, just remember this formula here. Okay. But B is okay, B for the watch, okay? Because okay, if it says 2000 kilohertz, then you have to know that okay, as it's going to be as okay, that frequency has to be as okay expressed in megahertz to fit into this equation here. So you will have to convert it into megahertz. Or as okay, if the value is given as okay in gigahertz, you have to be able to as okay convert it or find its worth in megahertz. Okay. Now, after you calculate your math and say, well, okay, let's say it's okay, we determine that the wavelength, for instance. After doing your math, you say, well, okay, I calculated that, okay, that's my wavelength, well, let's say it's okay. Just for health sake, okay, that's okay, 1.5 millimeters. That's the wavelength that you calculated. But you may not find yes, okay, 1.54 as an actual answer. Or this number here with this unit here in your answers. Okay, there may be an answer which says 0.14 centimeters. Oh, that's the same. Did that make sense?
Kinda. Can you explain like 0.1 centimeters? Like, so you convert it from millimeters to centimeters first?
Exactly.
Okay.
Because listen, I said, doing your math here, you said, well, okay, I determined that, okay, as my wavelength, for instance, okay, was, you calculated out that, okay, your wavelength came out to, okay, let's say this much. Clear? Did that make sense?
Yeah.
That's the calculation that you got from, okay, as the previous, from this equation here.
Yes.
Now you're looking for the answer that says, okay, 1.54 millimeters. You don't come across it. Because that's going to use, okay, that says, okay, be 3, 4, 5 options of different numbers. You don't come across 1.54 millimeters. You may come across something that's okay, which may be expressed in, let's say, as okay, meters. You may come across something that may be expressed in micrometers. Okay. You may come across, okay, as something that is expressed in centimeters. Whichever, but no millimeters. And then you're going to be scratching your head. Or be lost because you don't know what is going to, yes, okay, be the worth of this. Either expressed in meters, micrometers, centimeters, and let's, go crazy and say it's okay, nanometers. Clear? So you can say it's okay, 1.54 millimeters is going to be as okay equal to as okay 0.154 centimeters. So that's okay. The answer that said centimeter was the right thing. Okay. You may see, let's say it's okay, the same number as okay, as it says okay, micrometers. If you choose this one, then that's wrong because this many millimeters here is going to be as okay be equal to this many micrometers. Okay. So you have to know, yes, okay, how to convert from one unit into another. So how many micros are there in a milli? How many micros do you have in a milli?
1,000.
1,000. Okay. How many gigas do you have in a kilo? How many gigas will make up a kilo? How many gigas will make up a kilo? One of a millionth.
You said 1 million?
1 over a millionth. Why?
Million to the TH or
Million to the
Just million.
pH? Where does pH
not
come in?
PH, I said TH, millionth with the
Yeah.
TH. Okay.
Or 1 over a million, right? Why? Because I expressed the worth of a bigger unit expressing it in a smaller unit. Okay, or how many
that-
bigs do we have in a small?
And that's the one where you put the negative.
It's a
exponent.
fraction, yes.
Okay. All right.
Clear? So goals you have, and I asked 3 times now and I didn't get a reply. That's a divorce. That's a divorce. Or you can say it's okay, if the priest or pastor asks you 3 times, do you take this man or do you take this woman? And you don't answer, then that's a no. Yes, Marianne, you have different experiences? Or a different point of view? No, okay. And what are you, okay? And please, girls, wavelength and speed. Speed affects the wavelength, or wavelength does not affect the speed. You can put it that way, right? Okay, and wavelength was the only one of your 3, no, sorry, not 3, 7 acoustic parameters that is going to be determined primarily by both source and medium.
You repeat that, please.
Amida,
Can you repeat that, please?
I don't need to repeat it. It's written as a hint.
Where? In the book?
Yes, in the book.
Okay.
If you look on page 33, there's a box that says hint.
Oh, I see. Okay.
Okay. What did I say yesterday about the hints?
They're
They're not in a purple, pinkish color, just look beautiful. That purplish, pinkish color is mainly as okay, that she is okay. Catch your attention. So those hint boxes are must to know points. Did that make sense?
Yeah.
So whenever you come across something like that, mark it. or it is marked. Clear?
Yes.
So what determines the frequency? What determines the frequency?
Period.
Nope.
Okay.
Now, when we- huh?
The source.
The source. Clear? Now, when we say as okay, determined by, that's going to mainly as okay mean as okay the two things that may as okay affect the sound, which is going to be as okay either the source that produces it or the medium through which it's traveled. Okay. So period is wholly and solely as okay determined by the source. The period of a sound wave is not going to change as it travels through the medium. If the sound wave was, let's say, as okay, had a period of okay as 1 microsecond, as it is produced by the transducer, it will remain 1 microsecond even as it travels through the different tissues. Whether that is bone, blood, liver, muscles, tendons, whatever the hell it is.
I have a question.
Hmm.
So the frequency is the one that changes when it travels through
No,
the.
no, no. The frequency remains the same
Okay.
because that was also only determined by the source.
And the source is the transducer, or
Transducer.
the transducer.
Your source, Dr. Kin, where have you been all these days?
Right here.
Okay, I don't think so, because that's something that probably have been, yes, okay, repeating ever since we started chapter 2.
Yeah.
Your source is the transducer, or yes, okay, until and unless specified otherwise, could also be yes, okay, your system,
It's a lot of
which is that big
information.
piece of machine. Okay,
Yes.
good. Okay, likewise, yes, okay, whoever is speaking, he or she is the source of sound.
Mm.
Does that make sense?
Yes.
Okay, so where is that your ultrasound is going to be produced from? The ultrasound machine.
Yes.
Clear?
Yes.
Now the medium, right now as we are talking, is okay, the atmosphere around us is the medium.
Mm.
Clear? In ultrasound, the medium is going to be nothing, is going to be as okay, your tissues. What are your tissues? Muscles, skin, fat, lungs. Exactly. Bones, all that. That's going to be your tissues, or that's going to be as okay, the medium. Did that make sense?
Yes.
Okay. So it doesn't really matter as transducer that produces, let's say, it's okay, a 5 megahertz frequency. As that sound wave travels through the different mediums, bones, muscles, lungs, liver, tendon, whatever, that frequency remains constant. It's not going to go from 5 megahertz to 7 megahertz, from 7 megahertz to 8 megahertz, 8 megahertz to 2 megahertz.
Okay.
The only thing that will change in the sound as it travels through the medium for now is the wavelength. Why? Because the speed changes. Clear? That's going to become more clear as okay once we get on to yes, okay, talking about the propagation speed, which is going to be as okay, the last of our 3 of 7 parameters that we'll talk about. But wavelength mainly is okay because it is related to the speed of sound. It will change as the speed changes. Clear? But the wavelength will not change the speed. So speed changes the wavelength. Clear? But wavelength doesn't change the speed. Now here is okay, we say it's okay, 1.54 millimeters. That value is actually just okay derived from the speed of sound in soft tissue. But they're going to be as okay tissues in which the sound is going to be as okay traveling at a lower speed than 1.54. For instance, lung. In that case, that's okay, your wavelength will be smaller. Whereas, okay, yes, in tissues where it's okay, the bone that's okay, we can say it's okay, where the speed of sound travels faster, the wavelength will increase. And that's why we say it's okay. Not only is it the source that determines the wavelength, but also the medium, because that wavelength is going to change as it travels through the medium or different media. Did that make sense?
Yes.
Okay. But yes, okay, for understanding, yes, okay, ultrasound, we can say it's okay, ultrasound physics. They made yes, okay, made a standard, yes, okay, a mean average tissue, which will be as okay, which we refer to as okay, the soft tissue. Now, some of you would say, Mike, we didn't talk about soft tissues in medical terms. We didn't talk of soft tissues in anatomy physiology. What kind of tissue? That's mainly as okay, just a tissue type made up for ultrasound. You don't find soft tissue mentioned in any book of anatomy and so on and so on. Clear? Okay. Any questions, girls? No? Good. D. Now, girls, then let's just go back and start talking about yes, okay, our three bigness parameters. Okay, and you will find those on page 27 in your book. So go back from wavelength on to page 27. Clear? Good. So we are still talking of parameters. Okay, these are still going to be parameters, but we can say as okay, the three, and we may as okay going to talk about okay, three or a group of three parameters here, which are going to be as okay, the three bigness parameters. Okay. Why do we call them the bigness parameters? Mainly because okay, these are going to be as okay parameters that mainly as okay we can say as okay, well, we can say as okay, describe how big, or we can not describe, we can say it's okay, determine how big or small sound wave is. Now, please, when I say it's okay, big or small, here it's okay, this big and small here is not related to wavelength. Not that bigness or smallness. Clear? Now goes the three bigness parameters are power, intensity, and the last one here is okay, mainly is okay, a term that we already is okay, have talked a bit about or briefly mentioned. Amplitude. If some of you don't know, yes, okay, when we talked about amplitude, then they have not been paying attention to, yes, okay, when we were doing interference. Clear? Okay, goals. So these three fellows here is okay, or these three different parameters here is okay, they are going to be as okay, what we'll call the bigness parameters. Now goals, before yes, okay, jumping into yes, okay, what these three bigness parameters here are. We can mainly say, okay, power and intensity. Power and intensity is okay. Both of these here are mainly as okay, going to be, can say as okay, parameters that, okay, yes, we can say okay, we can say okay, deals with the amount of sound energy that a sound wave carries. Or we can say, okay, a measurement of the amount of energy that or sound energy that a sound wave carries can be as okay expressed in two terms, which could be power and intensity. Clear? And what we then can say is okay, your amplitude. The amplitude mainly as okay is going to be as okay, all dependent upon the power and or the intensity. What is going to be, it says, okay, the physical size of the wave. Is it going to be as okay, big wave? Or is it going to be as okay, a small wave? Yeah, we mean yes, okay, I can say then, okay, yes. This here is the amplitude. Or this here is the amplitude. Oh, yes, okay, this is the amplitude and this is the amplitude. But it's all going to be determined upon yes, okay, whether we have a wave with a great power or less power. Whether that wave has a great intensity or a low intensity that will determine how big or small the sound wave is going to be. Or when we say power and intensity, that's mean as okay, going to is okay. Mainly talk about how much energy, or to be more specific, yes, okay, sound energy. Is it that okay, yes, that wave that is being produced is going to be carrying? Did you girls get that? Did you girls get that?
Yes.
So mainly as okay, what I like to do first is just okay. That's what's okay. Maybe jumping a little around here. We start off with power. Okay. We are going to just okay. Mainly just okay. Just start off with power as okay as our first bigness parameter to talk about. Clear? Now power goes, or you can say power, what is that going to be? We can mainly say, okay, that's going to be as okay, the rate of transfer of energy. Or we can also say, or the rate of transfer of energy. Oh, sorry. The rate at which work is done. Now, girls, you may come for rate here. Clear? Now, usually sorry, I don't know what the hell happened. Okay. So power first is okay, we're going to say it's okay. It was the rate of transfer of energy. Yeah. Or it could also say okay. We could also say it's okay. The rate at which work is done. Yep. Now, usually it's okay, as I said, it's okay when we talk about rate, it mainly it's okay. Rate here mainly it's okay means time. Yeah. So power main is going to be as okay when we say it's okay if this is a particle with energy. Clear? Now the transfer of that energy is mainly it's okay going to happen over to it's okay another particle. So it's okay either how fast does the power transfer from this particle to this particle is going to determine the power. Or we can also say, okay, how much energy is going to be transferred from this particle over to this particle. Both of that can account for power. Did that make sense? Okay, so either it's okay, how fast is it that the energy is transferred? Or how much energy is transferred from particle to particle? Now, girls, you can also say, okay, put in this context and says, okay, the rate at which work is done. Now, I may ask you girls something. Does anybody know, yes, okay, how work is defined?
We're supposed to know.
Yes. Or what is the definition of work?
I'm gonna take a guess and say how much energy and force is produced. No, okay.
Work is done. Now, girls, and yes, okay, you can say, yes, okay, when we talk work, it is not going to be, yes, okay, good enough to say that, okay, yes, we transfer this much energy. Okay. So yes, okay, may become handy, yes, okay. So work is actually, yes, okay, going to be, yes, okay, we can say, okay, when a force is applied on an object to move it. Not to move it, because it says, okay. And it moves. That's what you call work. Let me just give you guys a little example. Now you may have, yes, okay, a big log of piece of wood in your backyard. Now the work you want to get done is to move that log out of your backyard, right? Now you may hire a handyman or whatever and say, well, okay, listen, buddy, this is the task. Now what he is, okay, it's usually going to be a he, but anyways, what they will be doing is you may see as okay that they are pushing onto that log. What are they doing when they're pushing onto that log? You may see people as okay standing there as okay pushing onto the log or rock or whatever the hell it is. Okay. But what a guy who is okay talk physics is saying is they're transferring energy onto that log or rock or whatever. Okay. Now, if they are pushing or transferring energy and that energy is okay, is enough to move that rock or log, then work is done. Whereas if they just keep on pushing, and that rock, that log, or whatever it is that they were okay intending to move is not moving, then work is not done. So here is okay, Romain says, okay, when one particle hits another, it will transfer energy. Clear? It will transfer energy, but work is only going to be done if, okay, that other particle also is, okay, carries on some energy and, okay, is transferred over. Which may mean that, okay, it will move. Clear? So that will be as, okay, transfer of energy. That is going to be as, okay, expressed in power. Clear? And the amount of energy that is going to be transferred from one particle to another particle, or from one part to another part, is mainly as, okay, primarily going to be dependent upon how much energy came. Right, okay. Just like, okay, as anything is transferred that is going to be transferred is going, mainly as, okay, going to be dependent upon as, okay, how much came. Let me give an example here as well. Now, who wants to be a volunteer? Anybody want to volunteer for this example?
Yeah.
Okay, Dr. King is always there. Okay, good. Good. So, okay, we say as, okay, I give Dr. King $1,000. Okay. I say, well, okay, dear, okay, I don't have a bank account. Do you mind take this $1,000 as, okay, as, and yes, okay, send it to this bank account here. What are you doing? You'll put those $1,000 in your bank account. I mean, yes, okay, just send it. Or what there's, okay, in bank language may say, yes, okay, transfer it over to, yes, okay, another account, right?
Yeah.
Clear? Now, since you are only sending $1,000, that bank account, which is, okay, the money is being transferred, is not going to receive $2,000, right?
No.
Only if you put $1,000 on from your own pocket. I don't mind. Okay. Yeah. Okay. So the same here. That's okay. A particle can only, as, okay, receive the amount of energy that is being carried by, as, okay, the first particle that is going to, okay, transfer. Now, I may have given you, as, okay, $1,000.
Hmm.
And you put that $1,000 into your bank account. But
Mhm.
your bank account says, well, okay, every time you submit money, we're going to just, okay, charge you a submission fee of, let's say, 5%. You don't know. Banks have crazy rules. Okay. Okay. If you bring cash, well, okay, we're not going to ask you where that cash came from, but we're just going to take 5% of the money that you submitted. Okay. So that's okay. What ended up in your bank account is, okay, as if they took 10%. We are left with $900. Now you can only transfer $900 to, yes, okay, to that other account. Oh. Okay. Okay. No, I'm good. Did that make sense?
Yeah.
Clear? Now that person is, okay, when he or she is, okay, receives, his or her bank may also take, okay, as a certain percentage. So it's, okay, the amount of energy or the amount of money that, okay, he will be able to just, okay, say transfer onwards is going to be less. Okay. But mainly as, okay, just that, okay, as transfer of money or transfer of anything. Yes, okay, as a pen. Or we can say it's okay, this here is a pen. when I say, well, okay, fill out that sentence sheet and pass the sheet over. What are you doing? You're
Transfer.
transferring it over with the pen. So here is okay, powers me that's going to be as okay. Either how fast is it that energy is being transferred from that's okay, particle to particle, or we can say, okay, how much energy is being transferred. Clear? That is going to be as okay, from part to part to part to part. Me pushing on that log or rock. If the energy or the force that I apply is not great enough to move that log or rock, is not enough power. I may say, well, okay, you know what, buddy? I may need, okay, as a bobcat or a tractor or something that, okay, as can actually, is okay, tie on to this, okay, and boom, pull it out. Clear? Then the power that is going to, yes, okay, be used here is going to be the power from, yes, okay, that tractor. Okay. Which means, yes, okay, just gets its power from, yes, okay, the gas and so on, so that the engine uses to run.
I have a question.
Yo,
So like if I'm the one pushing on the rock,
Hmm.
I'm the one transferring the power.
exactly.
Okay.
Clear? Okay. So whoever is okay applying the force, and that's what he says, okay, applying a force.
Mhm.
Okay. And if that force is okay, is able to, okay, move a object. Now it may not sound as much, but yes, okay, you see a pen on the table. You grab it with your fingers and lift it up. You grabbing like this, it means, okay, transferring force, and okay, yes, moving it up. That's work. But if you just put your hand onto the pen as it is on the table, but don't move it, then okay, work is not done in terms of physics. Or you can say, yes, okay, that log or whatsoever. If you come back after this, okay, 2 hours, because I say, well, okay, that may take up me 2 hours, yes, okay, move that rock from your backyard. And you come back and you see, well, I'm standing there, yes, okay, drenching in sweat. But the rock is still, yes, okay, where it was when you left 2 hours ago. You may say, dear, well, okay, the work is not done. Literally, yes, okay, it isn't done because, okay, the agreement was that, okay, as I move that log or rock from your backyard, right? Clear? Okay. But as okay, here we are not talking of okay, yes, but that's mainly as okay how work is defined. So whenever as okay a force is applied on an object and the object is moved, then you will say that okay, yes, work is done. Okay, it doesn't have to be a rock, a log. It could be as okay a simple thing like okay as a cell phone, a pen, a piece of candle, whatever. Even as okay, stirring as okay a spoon in a cup of tea or coffee. Because what is it you're doing? You're transferring a force onto that spoon, and okay, that spoon is being moved. Did that make sense? Okay, but you can say here, that's okay, you can say the faster you move the spoon, more work is being done because you're doing more movement in a shorter period of time. Or literally, that's okay, what you're doing is that's okay, you're transferring more energy onto that spoon. Did that make sense? So you use more power. Did you girls get that? Okay. Now the unit for power. The unit for power, girls, is going to be watts. And the easiest cheat to remember this one here is okay. It is okay, going to be is okay, the power of, okay, you can say it's okay, your bulbs. Because it's okay, earlier it's okay, electronic gadgets and so on, so that you have in your household. Now you may, it's okay, next time you go and it's okay, let's say it's okay, buy bulbs. You may see that, okay, as some bulbs maybe it's okay, 20 watts. You may have other bulbs which may be, let's say, as okay, 60 watts. You may have, okay, as bulbs which may be, let's say, as okay, 100 watts. You may go to as okay to the crazy aisle with okay as mega bulbs, which is going to be as okay 1,000 watts. So what does the different watts here mean? You can mainly say it's okay that this watt bulb here is going to just okay be the one that lose the least power. This one here is okay, may use a little bit more power than the 20 watt. This one here may use more power than these bulbs here. And this one here is okay, that's going to be as okay. Use as okay the greatest amount of power. Or not really power, actually that's okay using more. Since we're talking of electrical bulbs, that's okay, is going to is okay. This power here is going to be electrical energy. Because power mainly is okay, just was okay as a measurement of, because it's about how much energy is being used and how fast. Now you can say it's okay, the 20 watt bulb, mainly because it's okay, uses less electrical energy. That's okay, that's going to be as okay, a relatively weak light. The light from that produced by a 60 watt bulb is going to as okay, be as okay. We can say strong. The light produced by a 100 watt bulb is going to be stronger. And this one here is okay, that is going to be as okay, the strongest light. That pretty much okay, as you can say it's okay with a 1,000 watt bulb, you may be as okay able to just okay lit up your whole backyard. But my girls, if you just okay replace all your 100 watt bulbs, sorry, if you replace all just okay the sockets, that says okay that your house right now is equipped with 100 watt bulbs, and you replace them all by just okay 1,000 watt bulbs. Well, okay, you will find that okay, your house is going to just okay more well lit. But you can also then say that okay, as when you get your electrical bill from UI, it may have increased as okay at 10 times. Because what was it that you did? You now use as okay 10 times the amount of energy by using 1,000 watt bulbs that you used to do when you use 100 watt bulbs. So your bill used to be as okay, $20. Let's say it's okay, you don't have other gadgets. Just use bulbs. Your bulb then now maybe $200. Because your energy consumption was increased 10 times. Why? Because you use higher power bulbs. Okay. But on the other hand, you can also say, okay, the light produced by 1,000 watt bulbs or 1,000 bulb or 1,000 watt bulb, sorry, may be as okay equal to the light produced by 1,000 watt bulbs. Did that make sense? So that's okay. If you're having a barbecue party in your backyard, you may say, well, okay, I can buy one of those as okay, crazy lightning things, which okay, as we use okay as a heavy duty bulb, 1,000 watts. One of that may be enough to just okay, lit up your backyard so you can actually see what's going on during the barbecue party. Or you may as okay, place as okay, 10 different yes, okay, bulb holders with okay, 100 watt bulbs. And it's going to lit up the same, but okay, yes, you may just have to spend more money as okay, buying 10 bulbs of 100 watts. So when they say as okay, something is energy efficient these days, that's mainly as okay because it will use less power, it will use less energy, and transfer more of that energy into as okay, energy that will be used by that gadget. So a more efficient transfer, if you can put it that way. Dr. King, are you still there? Dr. King, I paid you $1,000 earlier.
You did. I'm right here. I'm
So
sorry.
if your bank check, okay, as 10% as a fee,
Yeah.
you may say, okay, no, that's not money efficient.
Mm.
I may need to look for another bank. That okay, as if I as okay submit cash into my bank account, they will not charge me any or take off any percentage, right?
Mm.
Or if they do, at least not 10%.
No.
Because the more money I submit, that's okay, the bigger and bigger shares that you guys will be taking off. So you say, well, okay, if it's 0.5%, that's okay. Because okay, if I submit just okay, let's say $1,000, they may just take off $5 as a fee.
Yeah.
But 10% is too much. Okay, or I lost $100 by putting in $1,000 cash. So that's why it's okay. You can say it's okay. A money efficient bank comes in.
Mm.
Okay.
Do I
Yeah.
still owe you $1,000 if they take?
No, you don't owe me anything. There's just an example.
What if I take 10% for myself? I'm just saying.
Well, okay, then you shouldn't be blaming that. Then you are not an efficient transfer. Then.
I'll blame it on the bank.
Right, okay, but clear.
Yeah.
Okay, so that's mainly as okay going to be power. So we can mainly say okay, straightly forward. What is the power is going to be as okay, mainly as okay, a measurement of how much energy is being transferred. Clear? How much energy is being transferred, that is mainly as okay, what we will call the power.
Okay.
Clear? But a particle or as okay, something can only as okay transfer as much energy as it has. Clear? If I was 100 watt bulb,
Mm.
I can only produce 100 watts of light energy. Clear? I may be, yes, okay, hooked up to, yes, okay, at your 1,000-watt electrical wire. Two things can happen. I will still only be able to, yes, okay, transfer 100 watts because I'm a 100-watt bulb.
Right.
But that 1,000-watt energy may, yes, okay, blow me up.
Oh, that's what happens when the light blows, like a light bulb.
Can be.
Okay.
Clear? We will talk more about that. It's not just that. It's me, yes, okay, just the fluctuation of light.
Okay.
Clear? So yes, okay, the unit here is important. Okay, but I gave you, yes, okay, so anything that you buy, they will say, okay, this many watts. They may go and say, okay, this many kilowatts. Now you just have to remember, yes, okay, what is going to be a kilowatt? Let me just ask you, how many watts do you have in a kilowatt?
1,000.
1,000 watts makes up a kilowatt, right?
Yeah.
Okay, so you can say it's okay, either a 1,000-watt bulb or a 1 kilowatt bulb. Just because, okay, the number is low, doesn't mean that it's going to be, it's okay, more. Or it says, okay, less energy consuming because, okay, the K actually means 1,000. So 1 kilowatt is equal to 1,000 watts. Did that make sense?
Yes.
Right, okay. Now, ladies, the typical value for this one here, you don't need to worry about it. Okay, it is mentioned, but it's not something that you're going to be asked about. I will have to know. Clear? Okay. Is that clear? But what you mainly can see is that, okay, yes, you're talking of milliwatts. Okay. Okay. Which is tau 1,000th of a watt. Clear? Okay. So it's really not just for this, from this value here, okay, you can see that, okay, it's ultrasound, even at its max, are low energy tests. Compared to, yes, okay, you can say, it's okay, other, yes, okay, imaging diagnostic modalities like CAT scans, X-rays, MRIs, so and so, that huge amount of energy. That's why you probably don't see, yes, okay, a portable CT scan machine. It may be portable, yes, okay, but okay, as in a mega truck. Right? Okay. Clear? So yes, okay, the typical value for, yes, okay, for your power, yes, okay, power is not a value that you need to memorize. Okay. You can maybe say the only takeaway here is that, okay, yes, it is low energy test. It's a test that uses low amounts of energy. Clear? And that's pretty much, okay, yes, what makes ultrasound relatively a safe diagnostic or diagnostic imaging modality. Whereas, okay, bioeffects or biological effects is mainly, that's okay, something that only theoretically exists so far. Clear, girls? Good. Now, girls, determined by what is going to, yes, okay, to determine the amount of energy of the ultrasound wave. Or we can say, okay, determine the power of the ultrasound wave. And girls, please pay close attention, because power is going to, yes, okay, be determined by the source. Now, girls, what we mean by the source here is not going to be the transducer, that's going to be, yes, okay, the ultrasound system. So we can maybe say, okay, if this, for instance, okay, was your ultrasound machine. That's not a robot crying, okay? This means, okay, this part here, okay, that's your screen. But this is your ultrasound system, and we can mean it says, okay, that this here is okay. That would be, yes, okay, your transducer. So practically, goal, that's okay, is going to be, as okay, the system, which is okay as a part of the source that, okay, as will determine the amount of power, or because it's okay, the power of the sound wave, which mainly is okay, just was how much sound energy is it that, okay, yes, the transducer here is going to be, as okay, producing. Is that clear?
Yeah.
Good. Okay, so if it produces, let's say, as okay, 1 milliwatt. That 1 milliwatt here, that's going to, as okay, be, as okay, produced by the system. Practically, as okay, where does that 1 milliwatt come from? Well, okay, yes, your ultrasound machine is going to, as okay, be running on electrical energy, because it's okay, attached into an electrical circuit. Where electrical energy is okay, goes to the system. From the system, goes to the transducer. And it's made as okay, going to be as okay in the transducer, where that electrical energy is okay, will be converted into sound energy and then transmitted. How and so on, so we talk more about that in a later chapter, which is going to be chapter number 8. Clear? Okay. Now, we may say as okay, we may have okay, yes. Let's say it's okay, 1 watt of electrical energy being transferred. Now that's going to be later. Now, one other thing that it says, so yes, okay, if you read the first sentence, okay, power, yes, okay, determined by, you will see as okay, that it's a source, and as okay, what we mainly as okay mean by source here is going to be as okay, the ultrasound system. And what we mainly can say is okay, that is going to be as okay, we can say that will be as okay, mainly as okay, what is going to as okay, determine your, because it's okay, initial power of the ultrasound wave. So let me just read it up. Okay, now all this, like I said, just like amplitude. Well, okay, it said so many because in the book, yes, okay, it has already talked about amplitude. Okay, but initial power is determined by the sound source. And what we mean by the sound source, yes, okay, that's going to be, yes, okay, the system. Okay, it even says that the ultrasound system, your machine, not the transducer. Is that clear? Now, the next sentence is important, which mainly says, okay, that the power decreases as the sound propagates through the body. So we can mainly say, okay, we might have started off with, let's say, okay, with a power of 1 milliwatt sound energy in the transducer. But as that power, or as that sound wave, which is mainly, okay, just energy, propagates through the body, travels deeper and deeper and deeper, what is going to happen? The amount of energy is going to, it's okay, decrease. So what might have started off as a volt, that's okay, as sound energy of 1 milliwatt, may end up as just 0.001 milliwatt energy at a deeper depth. Did that make sense? And what we mainly as okay will say that this energy here is okay will be, this is going to be as okay your final power. So your initial power was, let's say, is okay, 1 milliwatt. As that travels through the tissue or through the body, it actually is okay, decreases. So what mainly will happen is okay, at a greater depth, XYZ centimeters, just okay, deep into the body, the amount of energy that will reach there is reduced. Okay, and this is mainly as okay, where we as okay mentioned in chapter number 2 briefly, as an example of okay as acoustic propagation properties. Because it's made as okay, going to be as okay, because it's okay, the nature of the tissues that the sound wave travels through, that will determine, yes, okay, how much weakening or how much decrease or deduction is it that's going to happen in the power of the sound wave. But it will change as it travels through the body. Did that make sense? Clear? How that occurs, that's going to be as okay, something that we'll talk in more detail about in chapter number 6. Or we can put it this way. That $1,000 that I gave Dr. King Now, Dr. King did a little bit of hanky-panky. She said, okay, what if I keep something for myself? So she transferred SOK, sorry, SOK. She keep $10 with herself and transfer SOK or hand over $990 to who wants to be the next? Dr. Thomas. Now, Dr. Thomas only got $990. She may keep $20 for herself and transfer SOK $970 over to Dr. Abigail. And so on, so on, so on, so. And by the time SOK, the last person in the row here, SOK, receives the money, it's only going to be SOK $600. And I'll say, where in the hell did those other $400 go? Well, okay, yes. That amount decreased as a result of, yes, okay, the money going from person to person to person to person. Or you can say it's okay. Power decreases as it go from tissue to tissue to tissue to tissue. Did that make sense?
Yes.
Right, okay. So yes, okay. That is going to be as okay, what we in chapter number 6 will refer to as attenuation. Now don't go to chapter 6 yet. Okay? Don't go to chapter 6 yet, but I mean, yes, okay, just telling you so that you know that this point here is going to, okay, coming up again. For now, just remember your initial power is determined by the source. And what we in this case is okay mean as the source is your ultrasound system. It is not going to be the transducer. It's going to be the ultrasound system that is the source here. That will determine the power of sound energy. Clear? Okay. Now that sound energy that's going to be okay, something that your transducer will produce, all depending upon how much electrical energy it receives. The amount of electrical energy. Okay. But as that sound energy travels through the body, what is it that comes across? Different tissues. Tissues will have, yes, okay, their own acoustic propagation properties, which means, yes, okay, they are going to, yes, okay, affect the sound wave in their own way. Its effect upon or decreased as it travels. Did you girls get that? Any questions? Any questions, girls? Anybody want to say something? Nope. Okay, girls, then comes your adjustable. Is your power adjustable? Well, okay, girls, let's just, we can say, okay, let's just kill 3 birds with 1 stone. Okay, so as far as being adjustable, 3 birds are your 3 bigness parameters. They are all adjustable. Clear? And we can say, okay, the way by which we adjust them is the same. Now on your ultrasound system, when you look at that big piece of machinery, buttons and so and so. In most systems, girls, okay, sorry. In most systems, yes, okay, here on the left side, is there a knob or a button that is going to say, yes, okay, most likely it's going to be labeled as power output. So what does that tell you? Power. Now, most of the knobs and buttons says, okay, when you have them, it's going to, okay, be something that you'll be able to, you can say it's okay, rotate. So just like, okay, as the volume on your radio in your car, when you turn it clockwise, that will increase. So if you turn, yes, okay, this knob here clockwise, that's actually going to, yes, okay, increase your power output. Or you can mean it says, okay, the amount of energy that you will be telling the system to transfer will increase. Whereas, okay, if you turn it the other way around, like anti-clockwise, that is mean it's okay going to decrease. And what do? You reduce the amount of sound or electrical energy that is going to be as okay transferred to the transducer, and okay, you produce a low power sound wave. Or you can say it's okay, a low energy or low sound energy sound wave. So pretty much, okay, yes, we can say as okay, the practical of okay as ultrasound physics is very straightforward. It's merely as okay, just okay as turning a knob this way. No, sorry. Turning a knob this way. Oh, yes, okay, turning a knob that way. That's okay, may increase or decrease the power. That's going to say, okay, either increase or decrease the power of the sound wave. Okay, and that's going to say, okay, be the same for your intensity. That's going to be the same for your amplitude. Or you can say, okay, at least your output power intensity and amplitude of the sound wave is going to be controlled by that. Did you girls get that? Any questions? Any questions, girls? Now, right now, don't worry, because we're going to take that up once we're done with all the three bigness parameters. Right now, don't worry about it. Okay, it's a relationship to intensity and amplitude yet. Clear? Okay. So that's contagious, doctor. Okay. Read on your power. And not as okay, and especially that's okay, the 2 paragraphs of okay as determined by. Please make sure that you are okay as at least that's okay 80% clear of what that says. Clear? Okay. So read that paragraph over as okay a couple of times and make sure that you as okay understand each and every part of it. It says, okay, here it says just like amplitude, because amplitude was discussed on an earlier page. The initial power is determined by the source. What's going to be the source? The ultrasound system. And we just also said as okay, how is it that that be adjusted? Clear? So it is going to be as okay adjustable. You can increase the power, you can decrease the power. That's what it means to be adjusted, right? Okay. Just like okay, as if you buy as okay a pair of pants, for instance. That's okay. You can adjust the waist size. If it's too big, okay, you can make it smaller. Maybe it's okay by tying it with a belt. It's going to be as okay a little bit difficult. Just okay, increase the pant size. Okay. Anyways, clear. So power. Okay. The next thing is power decreases as the sound propagates through the body. Please highlight, underline, whatever you want to do with that one. Clear? And that is actually as okay described in the second paragraph. It says the rate at which power decreases as sound propagates through the body or propagates depends upon the characteristic of the medium and the wave. Okay. And that's going to be as okay an example of acoustic propagation property. And the acoustic propagation property that we were talking about in chapter 6 will be as okay attenuation. That's the major one. Okay. So yes, okay, that paragraph is okay, yes, very important. Okay. Any question, ladies? Okay. Just take, should we say, 15 minutes break, and I see you girls back at 11 o'clock with intensity. Okay, girls. Welcome back. Now, Any questions about power? Any questions about power? The amount of power transferred or the amount of energy being transferred. That's pretty much okay. That's what we would call power, right? Okay. Okay. And the energy that we primarily as okay we'll be dealing with here is sound energy. Okay. And now we can mainly as okay just go on to as okay our next bigness parameter. And that fellow is going to be intensity. Now goes, just look here. Intensity, that is going to be as okay the concentration of power. Or which means, I mean, you can say it's okay word to be energy per area. But we already know that, okay, here the unit is going to be, you can say it's okay, a unit of watts or a multiple of watts or yes, okay, a fraction of watts. Whereas you guys should already know that, okay, as the unit for area, that's going to be as okay, any unit of area or distance squared. Is that clear? Okay. Now they may, yes, okay, yes, okay, talk about as okay, the cross section of a beam. And we talk more about that, yes, okay, in chapter 5. The thing that is mainly as okay, going to be important here is going to be as okay, where is the relationship between power and intensity? An area of a beam and its intensity. Now, of course, if you guys can see it's okay, if you say it's okay, we want yes, okay, determine yes, okay, the relationship between intensity. And what I mean, yes, okay, is said was the numerator of, okay, as your definition here. That is straightforward. They're going to be directly proportional. And please keep in mind that, okay, as to establish that relationship, that's where we, okay, keep the area constant. Okay, so area is, okay, is going to be constant. That's how we will be able to, yes, okay, see, yes, okay, where is the direct relationship between intensity of a beam and the power of that beam, or the power of that beam and its intensity. Because what the power mean or what the intensity mean is going to be is, let me just go to the slide, is intensity mean will be that, okay, yes, if this is our power. And that power, as okay, is distributed in an area here, which could say it's okay. Let's just say this way. You just put that into the equation. And you can say it's okay, that intensity mean is going to be equal to these 10 watts here divided by 2 square centimeters. So in this case, yes, okay, water intensity comes out to is going to be, yes, okay, 5 watts per centimeter square. Clear? But we may say that, okay, yes, or what we just said was, on the previous slide was, that, okay, yes, intensity is going to be, yes, okay, directly proportional to power, which mainly means that, okay, yes, if the power increases, then the intensity will increase. And likewise, if the power decreases, then the intensity will decrease. There, okay, yes. Okay. Obvious, okay, we keep the area constant in that case. Because we also keep changing the area as we, okay, change the power. That change in the area is going to have its own effect on the intensity. Clear? So it's, yes, okay, determine, yes, okay, or establish the relationship between intensity and power. We keep the area constant. Now we can just, okay, go on an increasing of the power. As, okay, if we increase the power from 10 watts to, let's say, 30 watts. Now, what is that you will see happens to your intensity then? Okay, that's going to be, yes, okay, 30 watts, but now it's okay divided by an area, or it's okay distributed on an area of 2 centimeters square. So you will actually, as okay, end up with having, okay, as a intensity of 50 watts per centimeter square. So you see, it's okay, we increased the power 3 times. The intensity increased 3 times because 15 is 3 times greater than 3. Clear? Which means, yes, okay, just establish that, okay, yes, increasing power increases the intensity. Okay. Whereas if you go on the other way and say, well, okay, let's just decrease the power. We had, okay, yes, 10 watts, we decrease it, let's say it's okay, we go down to, yes, okay, 1 watt. Now you just put that into the formula and say, it's okay, what's going to be our intensity then? We have, okay, yes, 1 watt distributed in, okay, as the same area, which is, okay, as 2 centimeters square. And in this case, as, okay, your power is going to end up as, okay, as being half a watt per centimeter square. Which means says, okay, as we decrease the power from 10 watts to, that's okay, in this case, that's okay, 1 watt, well, okay, as our intensity went from, it's okay, being 5 watts to become, it's okay, half a watt. Did that make sense? So that's okay. Since we see increase in intensity with increase in power and a decrease in intensity with decrease in power, that made us, okay, establish that, okay, as power and intensity are directly proportional. But to establish that relationship, we keep just, okay, the third parameter in the equation here is, okay, constant. Did that make sense? So that's pretty much, okay, the same kind of relationship that we had between pressure and force, and density and mass, that we have between power and intensity. Did that make sense?
Yes.
Good. Okay. So whatever factor you're asking to us, okay, determine the value of, is always going to be as, okay, directly proportional to the numerator of the equation. Just as we said in wavelength. What did I say? That, okay, yes, if the speed will increase, or if the speed of sound will increase in a certain medium, yes, okay, the wavelength will increase. Although, yes, okay, the frequency in that case, yes, okay, will be kept constant. Clear? But wavelength and frequency are going to be inversely proportional, because when we calculated the wavelength, what did we do? We divided that speed by a bigger or smaller frequency. So that's when, okay, as the higher the frequency, the lower will be the wavelength. Or when we check, yes, okay, let's say pressure. And pressure, our denominator was area. So when we increase the area, what happened? The amount of force distributed on that area is going to be reduced. Or you say, okay, you end up with a lower pressure. Also for your density. The greater the volume in which, okay, as mass is being distributed, the lesser will be the density. Okay. So again here, we can mainly say, okay, so is there anybody who is in doubt about this? That pretty much, okay, yes, the intensity is directly proportional to power. And how do we increase power? How do we decrease power? I already told you guys that. And what is that going to do? That's going to, yes, okay, increase or decrease the density, oh, sorry, intensity of the sound wave. Did you ladies get that?
Yes.
Good. Let us just put it this way next. So we can then now say, it's okay, so what is now going to be, it's okay, the relationship between intensity and area, which mainly, as okay, just happens to be, as okay, your denominator of your equation, right? Now they are going to be inversely proportional, which mainly or mean that, okay, yes, an increase in area actually is going to, that's okay, decrease your density. Or vice versa. A decrease in the area is actually, that's okay, going to increase the intensity. But just keep it as, okay, to establish this relationship, what is it that we have to do? We have to keep power constant, because power is going to have, okay, as its own effect on the intensity. So if we keep on changing the power and the area, well, okay, that's not going to just, okay, establish the actual relationship between power and area, because that's also power and intensity, area and intensity, sorry. Because the intensity may also is okay get influenced by the changes in power. Okay, but we can mainly say it's okay. In any case, it's okay. We may have okay as a power, let's say it's okay 20 watts. Okay, we can start off with okay as a fixed area, or we can start off with okay as with an initial area and say our area here is going to be as okay 2 centimeters square. And on this 2 centimeters square is okay, we have a power of 20 watts. Now in this case, we can make that okay, what becomes our intensity? Our intensity mainly is okay, you just put this, that's okay, everything here is okay here in the formula. It becomes 20 watts over an area of 2 centimeters square. So the intensity, my goals is going to be 10 watts per centimeter square. Now what we may do is we can say, okay, let's just increase the area. Now when we increase the area, we can say, okay, let's just go on and say, okay, we increase the area of the circle from 2 centimeters square to, let's say, 20 centimeters squares. So now as made as okay, going to be as okay, a bigger area in which yes, okay, we distribute yes, okay, the same amount of energy. 20 watts. Now you may yes, okay, just put these values that's okay in the equation. And it becomes 20 watts per 20 square centimeter. Okay, now you may guess is okay, when you cut that, it becomes just okay 1 watt per centimeter square. So you said, okay, yes, we increased the power, but the intensity reduced. Now we may go the other way around and say, it's okay, what if we decrease the area? Okay, now we may say, okay, this is going to, okay, compare to, okay, our initial. So we decrease the area down to, let's say, it's okay, 1 centimeter square, from 2 to 1 centimeter. The power is the same, 20 watts per centimeter, 20 watts. So immediately, okay, just put that into the formula, and the decreased power now is going to be 1 centimeter. Area is going to be as okay 1 centimeter square. So what you end up with? You end up with an intensity of okay as 20 centimeters or 20 watts per centimeter square. As a result of okay as increasing the area, decreasing the area. Okay, you decrease the area, but you end up with a higher intensity. And all these instances, as you can see, okay, then you had this area which was 2 centimeters, which was going to be okay our initial standard. From where we is okay, me is okay, just go on and increase and decrease. We end up with 10 watts per centimeter square. We increase the area, our intensity is okay, got reduced. When we increase the area, the intensity got increased. So that mainly as okay establishes that okay as that intensity is inversely proportional to area. Did that make sense? Did that make sense?
Yes.
Yeah.
Good. Clear? And the unit of intensity goes. Okay, the unit of intensity is going to be the same. It's going to be as okay, the unit of power per unit of area. Now in chapter number 5, we will have as a whole detailed account discussion about yes, okay, intensity. Okay, whereas okay, we actually we'll be coming across okay 2 types of intensities, or 2, we can say okay, ways of looking at an intensity. Clear? But irrespective of okay, as whether that's going to be okay over here is okay, we'll call it okay, a spatial intensity, or it's okay, temporal intensity. The unit is always going to be the same. It's going to be as okay, unit of area power by unit of area, which is going to be as okay, watts per area, which is going to be as okay, any unit of distance squared. Did you girls get that?
Yes.
Good. And of course, yes, okay, then yes, okay, the relationship is going to be as okay, important. Clear? So here we can mean yes, okay, the main yes, okay, thing that we yes, okay, just established was the power is directly proportional to intensity. But we can say it's okay, this one here and this one here is okay, they were both bigness parameters. Clear? And whereas okay, as we started talking about okay, the first thing that I mentioned in terms of okay, as bigness parameters was that both of these bigness parameters yes, okay, mainly as okay, are going to be as okay, some sort of, because it's okay, measuring the amount of energy of the sound wave. Where okay, as that may be as okay, a great amount if the power is great, which is just going to make it okay, the intensity of that sound wave great. Or as okay, that amount may be less. If the power is less, which is going to just okay, make that intensity of the sound wave less. Is that clear? Now, maybe as okay, some of you may think it of as okay, as a sick example. But okay, as to understand the relationship between energy and intensity. Now, you may have a quiz coming up somewhere soon, right? Right? Listen.
Yes.
Good. Now, for that quiz, okay, yes, I may say, well, okay, girls, these are the chapters that will be yes, okay, on the quiz. Clear? You can mainly says, okay, maybe a day or so is okay before the quiz. We may take, okay, as a review session, where you can ask, okay, as whatever concerns, questions, etc., you have. But when you as okay are preparing for a quiz, what is it that you are going to as okay be focused on? Just say it, okay, let me just say, your first quiz is going to be as okay, chapter 1, 2, 3, 4, and 5. We might already have, it's okay, we might already have finished chapter 6 by that time. But what are going to be as okay, the 5 chapters that you will be focused on when preparing for your quiz, chapter 1 to 5, right? So that's going to be as okay where you as okay how yes okay do the intent study. What would intent study mean? That you put more energy into those chapters, right? Clear? And you can maybe say, okay, maybe because the number of chapters is less, it's just 5 chapters. You'll be able to just okay put more energy into each chapter. Now, when we go to the midterm, you know that your midterms are accumulative, right? I'd like to talk about the final. You may say, well, okay, in spite of, okay, as consuming as, okay, this many Red Bulls, this many Monster drinks, this many as, okay, cups of espresso, cappuccino, coffee, whatever. This is the max amount of energy that I can put into this thing here. So you may not be able to, as okay, do as an intensive study for all 24 chapters for your final. Right? Because that's okay, what do? It's the same amount of energy that your previous, okay, for one quiz just use just okay, focus on 3 chapters or 5 chapters. For another quiz is okay, 4 or 5 chapters. For a midterm, maybe is okay, 12, 13 chapters. But for the final, is okay, 24 chapters. Or you may say, well, okay, I'm not going to just okay, use energy on cooking, doing laundry, cleaning, babysitting, grocery shopping, so on, so on, so. All of my energy is going to be okay, focused onto the this dude here. That's when you can increase the intensity. But if you just okay, spread your energy all over this fellow here, doing grocery, doing this, doing that, doing that, doing that, doing that, doing that, what's going to happen? The amount of energy is okay distributed to this fellow here is going to be less. Did that make sense? Or you may say, well, I'm not able to concentrate that much. So when you say intensive study, that's when you sit down and says, okay, well, right now I'm in a vacuum. I can't be heard, I can't hear, I can't be seen, I can't see. Clear? So 100% focus on your, that's okay, whatever you task you are dealing with. Did that make sense? Now, different people may have, okay, different way of focusing. Okay. Or you can say it's okay, different way of studying. Now, girls, that's okay. The class session meeting is okay because we are not in person. Or it's okay present, or it's okay the campus or school or in the building or whatever. Everybody is sitting in their own living room, family room, bedroom, kitchen, whatever. This class here should be as okay where we can say it's okay. Where we can have a discussion. So when I say discussion, yes, okay, girls, please say something. Because it's okay, you may learn from me and I may learn from you. Who knows?
I have a question.
Yes, my dear.
So when you talk about the vacuum would be like an enclosed space, like if they ask a question.
Well, okay, you probably not won't. I would not recommend you enclose yourself in a vacuum because you're going to boom. But like, okay, you can maybe say, okay, like just one of my bosses used to said, but I'm not here now. Which means you says, okay, well, you see him standing right there, but he mainly meant, okay, right now, don't disturb me. Don't bring up an issue and say, so and so is okay, I'm stuck here. What do you want me to do? Because I'm not going to be answering you because right now I'm focused on something else. I have to concentrate on this thing here, okay? Okay. I'll concentrate my energy on what I'm doing right now. Because this task is okay, it requires, you can say, it's okay, intense work. And a measurement of that intense work is just going to be what you call intensity.
Okay. Thank you.
Clear? So if somebody comes from the right and say, okay, oh, I got this issue here. Do you want to look at it? What is it that he or she would have to have done then?
Focus.
Takes his or her eyes off what he was doing and okay, looking at, okay, yeah. And what happened then?
Just switching back and forth to the energy.
Switch. And okay, yes, he would not be as focused. Did that make sense?
Yeah.
Okay. Any questions? Because just okay, it goes. Another thing that is going to become very relevant when we talk of intensity is going to be focusing. Now, what do you mean by focusing? Let's say it's okay, you're looking at a big painting or a big wall mural or something like that. Huge. A lot of things on that mural or painting. Clear? But you're not concerned about it. Okay, where's in the upper right corner, left corner, lower right corner, left corner. There's made as okay, just a little dot on the nose of a person in that mural or painting. And that's what you're focused on. What does that mean? That you don't see what's around it. Or that's not, at least not what is catching your attention. The point that call your attention is, okay, at that dot on the nose of that person. Whose picture you're looking at, or whatever. Okay. So, focus is going to be as okay where you have the max intensity. Just mind that down. Okay, girls. The typical value of intensity. Well, okay, it is mainly as okay going to be relevant in terms of okay as bioeffects, which is going to be as okay what we'll come across in the last chapter. Yeah, okay. But it's not as okay, it's not a value or a typical value that okay as I will require you girls to yes okay know by heart. Okay. Now, like power, intensity is also as okay determined by the source. And what did we mean by source here? The system. Because we already have established the fact that we said, right, that's okay if we go like this and say, oh, sure. That this here is okay, this was our system. This was our power button. We increased the power by turning it clockwise. That was going to increase the intensity of the sound wave. Whereas you may say, okay, we decrease the power by turning it counterclockwise, which will mean as okay, going to as okay, decrease the intensity of the sound wave. So increasing the power, or we can say, okay, as power is increased or decreased, the intensity is going to increase and decrease. And power and intensity is going to, as okay, we can say as okay, suffer the same fate as it propagates through tissues. That it actually as okay will become weaker and weaker. Or actually it's okay will decrease. So here's okay, we had a great power. We had a great intensity. But as that's okay, the sound wave travels through the different tissues. We already said that okay, as the power is going to as okay, decrease, 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 decrease. Which mainly means that okay, as down here as okay, we'll have the lowest power, which mainly means that okay, we will end up with okay, as with the lowest intensity as well. Because intensity suffers the same fate as power. Did that make sense? Why? It's okay because it's the beam which has okay as a certain amount of energy. That energy is the power. As that power is reduced, the intensity of that beam reduces as well. Right? That $100 or $1,000. Let's say it's okay, I given that $1,000 to you, Dr. King, in a piggy bank. Clear? Because it says, okay, if the size of the piggy banks remain the same, it's physically as okay, that doesn't decrease. But it's okay, as it goes from your hand to somebody else's hand, somebody else's hand, somebody else's hand, okay, as everybody is okay, take out their good share of the money from that piggy bank. What's going to happen at the end? That same size piggy bank now with, okay, that's not $6,000, but just $600 or $500. Because it says, okay, the intensity of the money in that piggy bank is reduced to half. Same size piggy bank, but now half amount of money, right?
Yeah.
Did that make sense?
Yes.
Anybody didn't get that? Is there anybody who didn't get that? Anybody who didn't get that? Did everybody get it?
Yes.
Good. Thank you, dear. Okay, girls. Just take an early lunch break and we come back earlier today. And then we will, okay, talk the last bigness parameter and the relationship between all these three bigness parameters here and how to calculate them. Oops. Okay, how to calculate them in relation to one another. Okay, so I will see you girls back at no later than 12:40. Okay, have
Okay.
fun. Okay, girls. Okay, girls, welcome back. No, any questions? Any questions? No? So far you girls are good? Let's see. Okay, so let's check this. Now we can say as okay, the next bigness parameter is okay that we will talk about is going to be amplitude. Clear? And amplitude mainly as okay is just going to be, we can say okay. We can say okay. A measurement of how big, or on the other hand, how small a wave is. Clear? Now we can just okay, just take two examples and say it's okay if we have, for instance, okay, a big wave. This is a big wave because it's okay, it has a big amplitude. And on the other hand, we can say it's okay. This wave here is going, okay, just this wave here is going to be as okay. A small wave means it's okay because it has a small amplitude. Did you ladies get that? Okay. But then comes the yes, okay, the actual yes, okay definition of what is going to be yes, okay, the amplitude of, let's say, or orange wave here. And that's mainly as okay going to be as okay. We can say as okay either from the average line. Let's say okay, the meaning is okay, label this one here as the average line to the peak. Or from the average line to the trough. Is that clear? That is going to be as okay the amplitude of this wave here. There's the same as okay me as okay just apply for our other wave here. There we can mean it as okay that the amplitude of this wave here is going to be as okay from your average line to the peak, or from the average line to the trough. Clear? Did that make sense? Okay. So for our this wave here, this is going to be as okay your amplitude, or this is going to be the amplitude. Okay. Likewise for the blue wave, which is okay as a small wave with a small amplitude, this is going to be the amplitude, and this is going to be the amplitude. Did you guys get that? Or is there any doubt? Okay. Any questions, girls?
No.
Now the unit of your amplitude. Now the amplitude can mainly as okay can be expressed in all the 3 units of your acoustic variables, which was okay as the unit for pressure, which could have been yes okay pascals, or yes okay Newton per centimeter square or meter square or whatever. It could have been expressed in the unit of okay as density, which was going to yes okay B, because it's okay kilograms per centimeter square or kilograms per liter. And or it could be as okay expressed in okay as the distance. But mainly as okay to avoid all this confusion here. That's why they mainly says okay, what we are going to do is yes okay, we're going to yes okay express amplitude using yes okay somehow relative unit, which is going to be yes okay what we will call the decibels. Okay. So the amplitude of sound waves may as okay be expressed in the unit of decibels. Okay, where the abbreviation, or we can say okay, the symbol that is going to is okay express or be used for a decibels is going to be a lowercase d and an uppercase b. Okay, girls. Now, those of you who have as okay in one context or another as okay, being as okay talking about as okay regular sound wave, you may have come across as okay something like okay as, or you may have heard of the term decibels. Now, please, and I beg you, please do not mix that regular decibel with this. Yeah. Because in regular sound wave, yes, okay, when you talk about a decibel value of a sound, regular sound waves that you hear, that is going to be as okay related to the pitch of that sound. And not to be sexist or anything, that's not the point here. When comparing, yes, okay, the voice of a man versus a woman, the woman's voice have a greater pitch because it has a greater decibel value. And that makes okay, a woman's voice more shrieky. Whereas, okay, as the decibel value of a man's voice is low, which makes it more grave or deep. Okay. So here, yes, okay, the unit of decibel, that's okay, the term decibel is not going to have anything to do with that. Okay. The unit decibel, or dB, as you may abbreviate it as, is, as it says here, is going to, yes, okay, be a relative unit. So your amplitude is going to be expressed in a relative unit, which will be decibel. And what would it mean to, yes, okay, be relative? That is mainly as okay, where we as okay measure it with. We can say it's okay what we started with, which in today was okay as we started off at $1,000. But we ended up with just $500. Clear? And okay, as if I realize that okay, the $1,000 that I gave somebody ended up just being as okay paid off as $500 to yes, okay, the third party that I wanted that money to get you. I may say, girls, you know what? No, this is not doing the deal. So what I want you girls to do is just okay, send that piggy bank back to me, and okay, as whatever request is that okay, whatever money you took out, yes, okay, you put it back because you know what, girls, I can submit, I can yes, okay, hand that $1,000 to that person myself. Okay, so where did we go from here to here? Or from here to here? Comparing this $1,000 to $500, or $500 to $1,000, that change in both cases, that's okay, is going to, as okay, be expressed in terms of decibel. Okay. So whenever, yes, okay, we use the unit decibel, whenever we use the unit decibel, that's going to be as okay, a relative unit. Mainly as okay, just comparing between yes, okay, what we started off with versus what we end up with, or vice versa. Abigail, you are locked in 3 different places.
I'm not. It's all from my computer. I don't know what's going on.
Okay, that's fine. Okay, I just wanted to what the blue. Okay, that's okay. Okay, did that make sense? So we can mainly say, okay, when I passed out that piggy bank earlier today, it's okay, $1,000. It ended up with just $500, right? So we can actually say, okay, that's going to, it's okay, be reduced to half. That reduced to half can be expressed in terms of decibels. Because it's a relative term, it's a relative unit. Whereas if I say, well, okay, girls, that's not making, okay, this is probably, it's okay, a bad idea of me passing, it's okay, that piggy bank to somebody and say, okay, can you take care of it from here? So I may say, okay, you know, girls, just pass it back to me. That's okay. Started off his journey with, it's okay, 500 decibels, or it's okay, $500. Why I'm not just asking you to pass it back to me. I say, well, okay, you know what? Whatever you took out, put it back. So that's okay. It started off at $500, but when I receive it back, it's okay. It should have the $1,000. So that's okay. The amount actually doubled, right? That doubling is going to, yes, okay, be expressed in terms of decibels. How and so on, so on, so. That's something that we'll talk about later on. Right now, don't worry about that much detail about that. Okay, but goals, decibel is going to be as okay a unit that you will come across in several chapters. And it's always going to be the same. Comparing as okay where we start out to what we end up with. Clear? If you start large with a big amplitude, you can say, and you end up with, okay, as a lesser amplitude, the decibel value decreased. Whereas if you go the other way around, where you just, okay, start off with, okay, so okay, say a smaller amplitude, but you end up with, okay, as having a wave with a greater amplitude. That is going to be as okay an increase in the decibel value. The formula, the calculations of that, we will talk about as okay how that is done in chapter number 6. Right, okay. Did that make sense?
Yeah.
So decibel, you can take anything. Okay, you leave your house with, okay, that's $500. You spend $300. You come home, you only have $200. That difference of money in your wallet, you can say, okay, I'm $300 is okay, poor as far as, okay, as currency is concerned. But comparing those two, yes, okay, can be expressed in decibels. It may be the last day of the week before your payday or something. Your bank balance is $100. Your check gets submitted. Okay, your paycheck gets deposited, and okay, as now you are okay as $2,100. So me as okay, just comparing as okay, where was your bank balance before payday, and what is it as okay after payday, and be expressed in terms of decibels. But it's mainly as okay going to as okay be a relative change. So you can say okay, increased 10 times, 100 times, 1,000 times. You can say it's okay, doubled, 4 times, 5 times, 6 times, whatever. Did that make sense?
Yeah.
Anybody is in any doubt about this? Anybody want to say anything? Nope. Okay, girls, again, yes, okay. A typical value. Is that something, yes, okay, you need to worry about? No. Okay. So you don't really need, yes, okay, worry about, yes, okay, the typical value of the ultrasound. Here. Did you girls get that? Now, let us do it this way. Determined by. Now we already, yes, okay, kill one bird in, oh, yes, okay, because it's okay, 3 birds with 1 stone. Because we said power. And intensity. That's okay. And we now even see that's okay. And amplitude. Or we can mean is okay, say initials or initial power, initial intensity, and initial amplitude of the sound wave are going to, yes, okay, are determined by the source. Where yes, okay, here the source actually is okay, meant the ultrasound system. Okay. It is determined by that, but yes, okay, how was it adjusted? Because okay, they all as okay are adjustable in the same way by power. Clear. But we mainly said that okay, yes, if we increase the power, which means yes, okay, was meaning that yes, okay, we increase the amount of energy that the sound wave will be carrying, or it's going to be okay, a great sound wave energy. That will cause that okay, yes, the intensity of that sound wave will increase. And what that actually is okay will do was going to just okay increase the amplitude of the sound wave. Whereas okay, as on the other hand, we also said that if we decrease the power, that was going to just okay decrease the intensity, which then also yes, okay, is going to just okay decrease the amplitude. We have already as okay before as okay going on lunch break, we have already as okay, we can say as okay establish this relationship here. And what we mainly said generally was that okay, yes, power happens to be as okay direct straightforward as okay directly proportional to the intensity. Which mainly means that, okay, as if we double the power, the intensity will double. If we increase the power, let's say as, okay, 20 times, the intensity will increase 20 times. So does it go for, yes, okay, for the decrease. So they were directly proportional to one another. Did you girls get that? Clear? And what we also said was, well, okay, as power is, or as a sound wave is traveling, the power of that sound wave will decrease, which may also cause that, okay, as the intensity of that sound wave will decrease. Clear? Mainly as, okay, as a result of your acoustic propagation properties, the effect that the media has on the sound wave. Details of that, chapter 6. Is that clear so far? Now, the question then goes, okay, then what about intensity? Oh, sorry, amplitude. Now, we can mainly say as, okay, that to begin with, yes, okay, both power and amplitude, or both power and intensity, they both as well are going to, yes, okay, be directly proportional to the amplitude. Which mainly will mean that, okay, yes, a sound wave that had, okay, as a great power, because, okay, a high power sound wave. Mainly as, okay, because it carried just give me a second, girls. I'll be right back. It goes. Okay. So we can say it's, okay, a great power sound wave, which means, okay, you're going to have a great power because it carries a lot of energy. That energy, that's okay, that high power. Medina, Leisha, chill. Yeah, go to mama. Okay, that great power energy is going to just, okay, have a great intensity. And that great intensity, as, okay, will lead to, as, okay, a great amplitude. Wave. So more energy or more power will lead to, as, okay, a great intensity, which actually is, okay, will produce, okay, as a big amplitude wave. Where, okay, as on the other side, we could say low power, lower intensity. Lower intensity, smaller amplitude wave. जिगरा Talasha, mama, talasha. Chalo, go. Did that make sense? Now, although here it's okay, we are not able to physically, let's say it's okay, see sound waves, right? Okay, it doesn't work that you say, okay, well, okay, here, there's a sound wave traveling right there. That's not how it goes. And that's why it's okay, we may call this thing here as okay, physics, because okay, some general laws of physics apply. Okay. So yes, okay, wherever you see waves in the ocean, you may see waves in the trees. Not slow wind. You can say, okay, that's going to be as okay, less wind energy. Clear? That's going to be as okay, a bare with okay, as a less intensity. And what do you have? Just small waves on the ocean, or you may just see as okay, a little bit is okay, slight movement of okay, let's say the leaves, the branches, and so on, the trees. Whereas, okay, if it is a strong wind, now what does it mean to be a strong wind? More wind energy, right? It's going to be as okay, a more intense. You mean yes, okay, you say yes, okay, I feel a greater pressure from the wind. If you, for instance, okay, I have to walk against that breeze of wind. Whereas, okay, if you then look at the trees, if you look at the water in the ocean or so on, and at the beach, you will see big waves. And what do those big waves tell you? Yes, okay, these are high amplitude waves. What makes them high amplitude waves? The greater amount of, in this case, yes, okay, wind energy. Did that make sense? Okay. And you may see that, okay, it's out there at the depth, yes, okay, far out in the ocean. It may be big waves. But it's okay, when those waves, just okay, comes towards, just okay, you can say the coast or the beach. Those waves that start off as huge waves out there, maybe it's okay, smaller waves. And that's why I say, well, okay, don't swim beyond this point in the ocean. Because, okay, at that point you may encounter, it's okay, big, strong waves. Did that make sense? Unless, okay, as we are in, okay, as a place of a tsunami. That's where actually it's okay, the waves amplitude or intensity or strength or power doesn't change. Okay. Did that make sense? So that's okay. That's a very easy way of actually looking at, okay, how is it that power is related to intensity, which is going to, yes, okay, be related to the amplitude. So to begin with, we can mainly say, okay, these three here are all directly proportional. When power increase is going to cause an increase in intensity, we have already talked about that. Likewise, okay, when power increases is also going to, okay, cause an increase in the amplitude. Okay, so since power and intensity are directly proportional, power and amplitude are directly proportional, that also makes intensity and power and intensity and amplitude directly proportional, which mainly mean if one increases, the two other will increase. If any of these two here is okay, or if any of these three here is okay, decreases, the two other will also decrease. Is that clear, girls? Did you girls get that? Okay, girls, now comes the nightmare. Okay, now comes the real nightmare. Not really nightmare. I'm going to try to just, okay, make it as simple as possible. Okay. So what we mainly have said is, okay, when power increases and intensity increases, when intensity increases, amplitude increases. Likewise, on the other side, we said, okay, when power decreases, intensity decreases, and amplitude decreases. Did that make sense? That's the beginning, but girls, we can actually, that's okay, take it to the next level. Which mainly will mean that, okay, yes, power is directly proportional to intensity, which is directly proportional to amplitude. Okay, but girls, the actual relationship is going to be this, which mainly is, okay, just briefly can also mean that, okay, yes, amplitude square is directly proportional to intensity. And which also is, okay, will mean that, okay, yes, power is, okay, that's going to be directly proportional to the same amplitude square. Now, what would that mean? It would still mean the same, that, okay, yes, if one of these decreases or increases, sorry, the two other will increase as well. And, okay, yes, on the other hand as well. If one decreases, then the other two also will decrease. Now, what that mainly will mean is, let's do it this way. Let's say that, okay, yes, the amplitude increases 2 times. Clear? Let's say it's, okay, we had an initial intensity or amplitude of, let's say it's, okay, 2. Let's just say that, okay, that's our initial intensity, sorry, also was 2. And, okay, yes, this was also 2. We can make this, okay, this was going to be 2 watts. This is going to be, this, okay, 2 watts per centimeter square. So yes, okay, doubling the amplitude. That is mainly, yes, okay, going to cause that, okay, yes. But since we say it's, okay, square, that's going to be, yes, okay, directly proportional to, yes, okay, or the change in the intensity is going to be, yes, okay, directly proportional to the square of 2. Which mainly will mean that here, this is going to, yes, okay, increase by the square volume of 2, which is 2 times 2. So your intensity actually is going to, yes, okay, increase 4 times. by a doubling of the amplitude. But you mainly can say as okay, here is okay, your final amplitude and intensity then is going to be as okay, 2 watts increasing 4 times, which is going to be as okay, 2 watts per centimeter square. The same will also as okay apply to your power. Where you say, well, okay, the amplitude only increased twice. Yeah. But that twice is going to be squared. Which means it means okay, 2 times 2. Which means it become 4. Yeah. Where you mainly can say as okay, now mainly mean that okay, as the power is going to as okay, increase 4 times. Now your power to begin with was 2 watts. But that 2 watts is going to as okay, increase 4 times. So your final intensity as okay became, or we can say as okay, 8 watts. We can still take as okay, let's say as okay, the same amplitude. But let's say it's okay, if the amplitude of brain is okay, increased 3 times. And we still have as okay, let's say it's okay, the same initial power, intensity and power of 2 watts and 2 watts per centimeter square. But to find as okay, how much change is it that's going to be in the power and how much change is that going to be in the intensity? We actually is okay, we need to is okay, say, what's the square of 3? And please keep going as okay, it's okay, it's not going to be as okay, 3 times 2. That's not what it means. This 3 squared here actually means 3 times 3. Which will be 9. So yes, okay, if your amplitude increases 3 times, that will mainly mean that that's going to be as okay a 9 time increase in your initial power. Where you actually see that it goes from 2 watts to become 18 watts. That it goes from 2 watts per centimeter squared to become 18 watts per centimeter squared.
I have a quick question.
Yes, my dear.
So we basically have to find the amplitude first and then increase it with the intensity and power.
No, not because they're going to give you something in the question to work with.
Okay, and then my next question is for amplitude. You said
Yeah.
it's increased by 3. So we basically square 3.
Exactly.
So whatever they tell us to square, whatever the number is that increased by, we square by
Whatever
that.
let me put it this way. Right? Whatever the change in the amplitude is, you square that.
Got it. Thank you.
Clear? You square that. And that's going to be as okay what you will find as a change in the power and the intensity. Clear? But what you mainly see here, no matter as okay, whether we as okay just double the amplitude or whether we triple the amplitude, but the change in the power and the change in the intensity is the same. Okay. So if we say if if the question tells you, or if you're being asked, well, okay, yes, you had a power. Let's say it's okay, you have a power of, let's say it's okay, 6 watts. Clear? And you had an intensity of, let's say it's okay, just to make it a little bit, that's okay. Because it's okay, 3 watts per centimeter square. Now they may say, oh, okay, listen, dear. What we just have here is okay, as we have a increase in the power. Let's say it's okay, the power just says okay, increases twice. What is going to be as okay, the change in your intensity? Now here you're not going to square out anything. Your intensity is mean as okay, that's going to be doubled as well. So that doubling is only as okay if you as okay compare the change in the amplitude to the change in intensity, or change in the amplitude and intensity of power. But when you compare change in power to change in amplitude, it's going to be the same. If power increases twice, intensity will increase twice. If power is okay, increase 10 times, intensity will increase 10 times. Did you get that? Okay.
Yeah,
So it's only if you, for instance, okay, I give and say, well, okay, this was the amplitude, or this was the initial amplitude. That initial amplitude increased twice. It increased 3 times. It increased 4 times. It increased, let's say it's okay, 10 times. What is going to be as okay, the change in your power? That's when you square. And by squaring, it doesn't mean to multiply by 2. It means whatever change, if it's twice, that it increases to twice its value. You may as okay, we'll just multiply 2 by 2, which gives you 4. If it's 3 times, you multiply 3 by 3, which becomes 9. Clear? If it's 4 times, you must multiply 4 by 4, which become 4 times 4 is what?
16.
16. If it's 5 times, 5 times 5 is 25. So your power will increase 25 times. Your power intensity will increase 25 times. But then be watchful, because they may just ask you how much change is there going to be in the power if the amplitude is increased twice. How much change is there going to be in the intensity if the amplitude is increased 3 times? Then you just squared. But they may ask you, yes, okay, what is going to be the final power? What is going to be, yes, okay, your final amplitude? And that's when you multiply your initial power by the time that it changes to get a number. Right? Just as we said here. Where we said, okay, yes. Amplitude increases twice. The change in intensity and the change in power is going to be 4 times. That's if they only ask you, yes, okay, how much is it that the power is going to change? Or how much is it going that the intensity will change by a doubling of the amplitude. The amplitude changes 3 times. Or you can say, okay, increases 3 times. What is going to be as okay? The change in the power and the change in the intensity is going to increase 9 times. Because the square of 3 was 9. Why? Because 3 times 3 is 9. But when they say, well, okay, you had an initial power of 2 watts. The amplitude increases twice. What is going to be your final power? That's when we say, okay, amplitude increases twice. That's going to mean that power will increase 4 times. I had an initial power of 2 watts. 2 times 4 becomes 8 watts. We had, okay, the initial intensity of 2 watts. Amplitude increased twice, which mean that power will increase 4 times. So my final intensity is going to be 8 watts per centimeter square. Okay. So the thing that you need to just, okay, you can say, okay, calculate is going to just, okay, be given in the question. Okay. But they may, yes, okay, go and say, well, okay, yes, what is your final power? What is your final power? And they may, yes, okay, be so cruel that give you this. And if you choose this as the right answer, well, okay, it's going to, yes, okay, it's going to be correct as far as, okay, as the change in your power is concerned. But that's not what they asked about. They asked, yes, okay, what is your final power? They may even go and, okay, put this as, okay, say 4 watts. Okay, girls? So you need to keep your eyes open. And that's pretty much, okay, that's what ultrasound all is about, to keep your eyes open. Or you can say, it's okay, be focused. So we can just go the other way and say, it's okay, where the amplitude decreases, it's the same. It's the same formula, it's the same, yes, okay, we can say it's okay, relationship or equation. Where we say, it's okay, we have a power. How should we make it a traffic light? We have an intensity. And we have an amplitude. Now let's just say that, okay, as the amplitude, and right now it's okay, we're talking of decreasing. But instead of going to, yes, okay, be squared. Amplitude change, or amplitude square. So let's say that, okay, as the amplitude decreases to half. Now, maybe that's okay to determine what's going to, yes, okay, be the change in the intensity or change in the power, for instance. That's going to be, yes, okay, that square of half, which mainly will mean half multiplied by half, which becomes 1/4. So in that case, that's okay. If your amplitude decreases to half its initial, there'll be 1/4. The intensity will reduce to 1/4. So light will be the power. You can go the other way and say, okay, what if the intensity or amplitude, reduces to 1/3? Now it's still going to be as okay, the square of 1/3, which means it will mean that 1/3 multiplied by 1/3, which becomes 1/9. So in that case, that's okay. You mainly as okay can then say that okay, yes, that your power and intensity is okay reduced to 1/9. Now you can say it's okay. We might have had okay. Let's say it's okay. Initial power. Let's say it's okay. 18 watts, for instance. Now, if that is increased to 1/4, that may mean that okay, as you would multiply 18 by 1/4, which means it'll be as okay, they mean the same as 18 divided by 4. So that's okay. That's going to give you as okay, what we can say is okay, will be the final power, whatever number you get. Okay. Which means okay, will be 5.4 volts. But at the same time, you can say, okay, what if my amplitude was decreased to 1/3? That's going to mean that it's going to be as okay. 1/9 of my power is going to be as okay, or my final power is going to be as okay, be 1/9 of what I ended up with, started with. Which means to me as okay, 19 divided by or multiplied by 1/9, which means to mean 18 divided by 9. Meaning you can say, okay, the final power is going to be as okay, 2 watts. And so on. So the relationship is okay. The first part of the relationship is when power increases and intensity increases, when intensity increases, amplitude increases. So all these three as okay, bigness parameters here as okay, are directly proportional to one another. But you can mainly say, okay, the change in the amplitude, or we can say, okay, the change in the power and the change in the amplitude is going to be as okay, the square of the change, the change in the power and the change in the intensity, is going to be the square of the change in the amplitude. Or you may say, well, okay, that's going to be as okay, a lesser change in the amplitude and greater change in the power. Lesser change in the amplitude and greater change in the intensity. Because the amplitude only is okay, increases twice, power increases 4 times. Likewise, Amplitude only changes, or yes, okay, doubles. Power increases, intensity increases 4 times. Amplitude is halved. Power becomes 1/4. Amplitude is halved, intensity is reduced to 1/4. Did that make sense? Okay. So you may be asked, okay, what is going to be as okay, the change in the power? What's going to be the change in the intensity if this is the change in your amplitude? Clear? But be watchful, because you may be asked, okay, this is a change in the power. It increased twice, or it is doubled. What is the change in the amplitude? Oh, sorry, intensity. Then that's going to be even. Because if the power is doubled, then the amplitude is doubled. So be watchful, girls. I'm just waring you. What to expect. You may be sitting there as okay, doing crazy calculations, which was not required because that's okay, that was not what you were asked about. It was straightforward. You may or may doing as okay, those calculations because you didn't know the actual relationship. Any last word of wisdom? Anybody want to say anything? How do you girls find physics? Is something sticking in your cerebral cortex?
It's okay so far. It's just that you have to understand and your relationships, then you'll be good, I think.
It comes down to the relationships, yes.
Yeah, so it's okay.
I hope it stays so. Clear? So adjustability, yes, okay, we already said it. Since they're all, yes, okay, directly related, and one control the other, control the other. Yes, okay, they are all adjustable in the same way. Clear? And they suffer the same fate. As sound wave travels through the body, its power will reduce. You can say it becomes okay, lower and lower and lower and lower energy. Which mean that okay, as the intensity will decrease. And please provided that okay, as the area remains the same. The area is an important factor. Clear? Why is okay, then the amplitude remains the same. Or you can say, okay, that's going to be as okay, a decrease as well. So all your 3 bigness parameters, whether that is power, the intensity, or the amplitude, are going to decrease as the sound wave travels through the body to deeper and deeper and deeper depths. That is mainly as okay, as a result of that's okay, what we call acoustic propagation properties, the effect of the medium. And what is the medium? Dr. King, what do we understand by medium?
The medium is the stuff that's getting passed through with the sound. So like the tissue would be the medium.
Tissue will be your medium, right? Okay. Right now, don't go into the speed factors.
Okay.
We talk about need for speed tomorrow.
Okay.
Okay. Okay. But it mainly says, okay, what is going to just okay be the effect of the medium upon the sound wave. And you can see straightforward here is okay, the effect that the medium had upon the sound wave was that okay, that sound wave's power is going to reduce. Since that power reduces, the intensity reduces. Since the intensity reduces, the amplitude will reduce or decrease. And that decrease in power, intensity, and amplitude is what we call attenuation, chapter 6. Any last question? So my girls, these were your bigness parameters. Okay, so tomorrow, yes, okay, what is it tomorrow? It's a national holiday, right? No?
I don't
think so. Just tomorrow's.
I think so, then, okay, wake up.
It's the 19th.
Thursday is the 19th. Tomorrow's Thursday, the 15th.
Yeah.
Okay, so what was it yesterday?
Oh,
13th.
14th.
Today's the 14th.
Today's the 14th? Man, listen.
So Monday is the 19th.
So isn't today a national holiday?
Isn't it Monday?
Isn't today a national holiday?
It's Flag Day.
Huh?
I don't know.
It's Flag Day.
So what happened on Flag Day?
I'm not really sure.
You're not really sure. Do you know anything about Flag Day?
Nope.
Nope. Oh, okay. It's just a date and they say named it for the flag. Oh, you never know. Okay. Whatever. Yeah, okay. Good that you mentioned it. You don't have class on Monday. It's okay. It's okay as because it's okay. Or observance of okay as Juneteenth. Okay. So hopefully, girls, tomorrow is okay. We'll be doing is okay. Need for speed. It's okay. Talk about propagation speed. One thing that you girls just have to remember for that one is that's okay. No fastest in solids, slower in liquids, and slower than gases. That may help you. Okay. And we'll talk a bit about it's okay. Different medias, which speed is fastest, propagation speed of sound, slower, slowest. And okay, as what are the factors that determines the speed of the medium? Or we can say what are the factors of the medium that helps determine the speed of the medium? Or let's say the speed of sound in that medium. And what are those relationships? And then we have some exercise. And okay, I guess let's see how far we get. Okay. Any last words? Okay. So girls, please read on your bigness parameters. There's not much to read on, but make sure that you understand the relationship, that you understand, like I said, the relationship between parameter to parameter to parameter. And it's okay, the relationship between power and intensity. And the relationship between intensity and area. Okay. And please be aware that intensity is a parameter and density is a
Variable.
variable. Exactly. Very good, dear. Okay, ladies. Have fun. And see you girls tomorrow.
See you tomorrow.
Okay, dears. Have fun.
Bye.
Bye bye, dear.